Hello, my name is Will Paris, and this is my Lab 3 Magnetic Fields of a Bar Magnet Lab. So this lab was conducted in order to observe and understand the magnetic field of bar magnets. We used the distance dependence of magnetic fields as well as the Biot-Savart Law in order to calculate the magnetic moment of the bar. So below we can see the Biot-Savart Law being dB equals mu I over 4 pi times dl cross r hat over r squared. And the distance dependence formula is the magnitude of the magnetic field of the bar is equal to k r to the n. And as a result of this lab, I found mu is equal to 2.21 A times meter squared, amps per meter squared. First we define the system as the bar magnet and the surroundings as everything else. So in this lab, we found the distance of a bar magnet from a magnometer at certain magnetic field values. So we did this by placing a phone on a magnometer app on a phone onto a yardstick and then moving the magnet away from the magnometer until we got to a certain magnetic field value and then wrote down the distance. We then flipped the phone 90 degrees in order to collect data for the y component of the magnetic field. So the data in the experiment was collected and linearized. The distance dependence formula was used to calculate the magnetic fields at each distance. So you can see we found it at our distance at 20 and 70 and 120 and 170 and 270 values for magnetic fields. And then we linearized it and graphed it. As we can see, the slope is negative. It's actually negative 2.5. So then we found our off-axis field, and then with our off-axis field, we could then calculate our B net that we could use in our Biot-Savart law. So the slope of the linearized line was used in the Biot-Savart equation as n. This n was found to be negative 2.5, but as I said earlier, then we can use the Biot-Savart equation. We can set it equal to the distance dependence equation and solve for mu. This is the magnetic moment, and we found that again to be 2.21. So this is the code I used on Python to simulate this. So I went through at all of my distances and I calculated what the perpendicular distance would be and what the b axis and the b perpendiculars would be to then find the b total, and then I made a nice visualization of the magnetic field in CodeScript, and here it is. So at the end, I found that my total distance was 0.234, and that my b at the 45-degree distance d is going to be 8.5329 e to the negative 6 and 2.5598 e to the negative 5 and 0 in the z hat. And then the magnitude of this is our B total that we found earlier. So possible sources of error could be the phone, magnometer may not be completely accurate, and human error in data collection. If we find the magnitude of this value of B, then it is, this was 8.53 and 2.55. It comes out to be around 5.5. And then as we found earlier in our presentation, we have 6.35, so we're off by just about a magnitude of 1 e to the negative 1, so about 10. So what if you hadn't oriented the experiment to compensate the magnetic north field and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? The results would change due to the principle of superposition. The results would be the magnetic field of the Earth plus the magnetic field of the bar. And then what if you were to stick two identical magnets together end to end and run the experiment again? Would you expect your measurements to differ? My measurements would have doubled due to the Biot-Savart law and distance dependence formula. So yes, that is all for my Lab 3.